Okay, welcome everyone. This time I'm going to solve some more random problems. So here's the first one. The sum to the first n terms of the series 1 by 2 plus 3 by 4 plus 7 by 8 plus 15 by 16 keeps on going till n terms, that is 9 plus 2 to the negative 10 power. So what is the value of n? Fine. So here's the thing, 1 by 2, that can be written as 1 minus 1 by 2, very obvious. 3 by 4 can be written as 1 minus 1 by 4. This thing can be written as 1 minus 1 by 8. And you get the fashion, right? So that's how it's going to go generally. So if you sum this up for n terms, there are going to be n ones. So you have n, then you have minus half plus 1 by 4 plus 1 by 8. And it keeps going like that till you have n terms. Okay, so that's supposed to be equal to n minus the first term is half times the common difference is 2 to the negative 1, so 2 to the negative 1 times n is negative n minus 1 upon 2 to the negative 1 is just half minus 1. So this guy is supposed to be equal to negative half, so this cancels with this and this becomes a plus. So this is supposed to be equal to n minus 1 plus 2 to the negative n. Alright, so now from this thing it is very clear that 9 plus 2 to the negative 10, this can happen only when n is 10, right? So n equals to 10 should be the answer. The next thing is, if Sn denotes the sum of the first n terms of a GB with the first term and the common ratio both positive, then so you have Sn, S2n and S3n form a GB. Let's just check that out. So Sn is supposed to be a times r to the n minus 1 upon r minus 1, right? S2n, that is supposed to be a times r to the 2n, which I'm going to write as r to the n minus 1 into r to the n plus 1 upon r minus 1. S3n, that is supposed to be a times r to the 3n minus 1, which can be written as a times r to the n minus 1 into r to the 2n plus yes, r to the n plus 1. Yeah, that should work, no problem, upon r minus 1. So from Sn to S2n, what's the ratio? That is supposed to be r to the n plus 1. And from S2n to S3n, what's the ratio? That is, I think, r to the 2n plus r to the n plus 1 upon r to the n plus 1. So are these things equal? I do not think so, because this when you multiply it, you get r to the 2n plus 2r to the n plus 1, which is not equal to this thing, right? You have an extra r to the n, and they are just telling us that r is a positive number and n is a natural number, I think. So that means that this thing is not supposed to be equal to that thing. So that's very clear that these are not in a GP, so that's incorrect. Okay, so the next thing is Sn, S2n minus n, I mean S2n minus S of n, and S3n minus S2n form a GP. That looks valid because Sn is supposed to be the sum of the first n natural numbers, which is supposed to be a1 plus a2. I think I should say a plus ar plus ar squared all the way till ar to the n minus 1, that is Sn. Right, this thing is supposed to be Sn. Then what is S of 2n? S of 2n is nothing but a plus ar squared, keeps on going till you have ar to the n minus 1 plus a times r to the n plus a times r to the n plus 1, keeps going till you have ar to the 2r minus 1. And then similarly S of 3n, I mean 3n minus 1, S of 3n, that's supposed to be a plus ar squared, I mean yes, plus ar to the n minus 1, I think I should say 2r minus 1, alright, ar to the 2n minus 1 power plus ar to the 2n, keeps on going till you have ar to the 3n minus 1. Alright, so now from this is very clear that if you take Sn, it's just this thing. Now S2n minus Sn, that is when you take all of these terms away, so you just have this thing but multiplied by r to the n. And S3n minus S2n, that's going to take all these terms away, so you just have this thing but multiplied by r to the n once again. So yes, these two form a GP. All right. Okay, fine. The next is S2n minus Sn, S3n minus S2n, and S3n minus Sn form a GP. So I'm not going to go into complete detail of solving all the algebra, but this does look obvious that these should not be forming a GP, because look at that. S2n minus n and S3n minus 2n, those have a difference of r to the n, alright. But S3n minus n, that's a different story. You just have this thing. You have, what do we say? Yeah, so it starts with ar to the n and then keeps going till you have ar to the 3n minus 1. So that's supposed to be ar to the n, and then how many terms are there? So yes, so you subtract n minus 1 from that, right? So that cancels. You have 2n terms, so r to the 2n minus 1 upon r minus 1, right? So yeah, that's correct. Now this thing is supposed to be Sn, so this is r to the 2n minus 1 of Sn, okay, which can be written as, we don't need to write it like anything. So if this was somehow equal to r to the 2n times Sn, I think it could have been, wait a second, r to the 3n minus, okay, so this thing is n time, I mean r to the n times Sn. This thing is r to the n squared times Sn. So this thing should have been r to the n cubed. Uh, yeah, r to the n cubed times Sn. But it didn't turn like that. It turned out to be something completely different, right? So yeah, that's not correct. So these are not in a GP. What about the next thing? So you got S2n minus n, S3n minus 2n, and oh, that's the same thing as before. Okay, fine. Just move on. So the next question says that if a, b, c, and x are real numbers, and oh, that's an important statement actually. These are like real numbers, and a square plus b square into x square minus 2b into a plus c plus b square plus c square equals to 0, then a, b, c are in. So you have AP, GP, HP, and none of these. So yes, this thing, right, this thing can be written as a squared x squared minus 2abx plus b squared, right, this b squared, this minus 2ab times x, and then you have a squared x squared, okay, plus b squared x squared, right, this thing, minus 2bcx, right, the remaining part, and then you have plus c squared, which can be written as ax minus b whole square plus bx minus c whole square, and this is supposed to be equal to 0. So when can this thing actually happen, that the sum of two squares is 0? This can only happen if both of these squares are in fact 0. So that gives me x equals to b by a, but x is also equal to c by b. So actually if you take a, b, c in their order, the common ratio, if these were to be in GP, that would be b by a and c by b, and that we can see is in fact common. So yes, these are in a GP, right? Move on to the next question. So find the sum of the series 1 into 3 square plus 2 into 5 square plus 3 into 7 squared up to 20 terms. All right. So what's the general form of every term that we are seeing? That is supposed to be r into 2r plus 1 square, right? Which is supposed to be equal to, like, this is tr, general term. Supposed to be equal to 4r cubed plus 4r squared plus r, yes. So if we sum this from r equals to 1 to 20, right, you are going to get 4 times n squared. I mean, n is 20, so just write 20 squared. Then you have n plus 1 squared, which is 21 squared, divided by 4, so these cancel away. Then you got plus 4 times r squared, so that will turn out to be n, which is 20, into n plus 1, which is 21, into 2n plus 1, which is 41, divided by 6, okay. And then for this last thing, you have r, so that will turn out to be n into n plus 1 upon 2, which is 20 into 21 upon 2. Alright, so if you do all the calculation correctly, you get this thing. So yes, that's the last question. Hope you enjoyed this video. I will see you in the next one.